welcome to Class Connect study series with Yusuf Arikewuyo. Today we shall be considering sound waves, production, its transmission and its speed in various media. Sound wave is produced whenever an object vibrates. Sound is a sensation to hearing. Sound wave is a longitudinal wave which requires a medium for its propagation. Whenever a source of sound is activated, it is usually observed that the direction of the wave is always parallel to the direction of the source. In an unperturbed medium, the particles of the medium are at normal pressure and uniformly distributed. This is the case for when we visit a quiet room. When we enter into the room and wait a period of time, we will notice that the room appears to be quiet or silent. The moment we make a sound, we affect the arrangement of the air particles in that particular room. And as such, we generate sound. Whenever sound wave is produced, there exists the formation of clustered and relaxed particle region. The region of clustered particles has high pressure above the normal pressure and is called the compression region or the compression zone, while the region below normal pressure is called the rarefaction region. Let's consider these two figures. In Fig 1 shown, we observe that the particles are uniformly spaced. This is the case of a silent room or a quiet environment. The air particles are uniformly spaced and distributed. In Fig 2, we notice regions of clustered particles and regions of relaxed particles. The regions of clustered particles is called the compression zone or the compression region, while the region of relaxed particles is called the rarefaction region. From the diagram, we can see that the compression zone corresponds to the maximum or the peak values. We can also say that is the point where the maximum frequency is obtained, while at the relaxed zone, the pressure is relaxed or reduced. Let's now consider the transmission of sound waves. For sound waves to be transmitted, it requires a medium such as solid, liquid, or gas. It should be added that the speed of sound is not uniform in all media. The speed of sound varies with respect to the media under consideration or the medium under consideration. Sound waves travel fastest in solid materials, then liquid, and the least in gases. Let's now look at the speed of sound in various media. As said earlier, the speed of sound varies in different media. The speed of sound is not uniform for all media, and it is dependent on salient factors such as 1. The nature of the medium. By nature of the medium, we are trying to consider the density of the medium. Are we considering a more dense medium or a less dense medium? For example, in solid, the density is very high. The particles in solid media or the particles in solid medium are usually packed together. They are closely packed together compared to the particles in liquid and also those of gases. Then 2, the temperature of the medium. By temperature of the medium, we try to consider if velocity or the speed of sound varies directly as that of sound. And experimentally, it is shown that the speed of sound varies directly as the temperature of the medium in which it propagates. And lastly, the direction of wind. Of course, wind plays a very key role in the speed of sound. For example, if the source of sound is moving against the listener would observe that the sound he or she picks up will be limited as the direction between the two spaces out. However, if the direction of the source and that of the listener are in line, that is on the same path, then the wind will aid the propagation of sound, and as such the listener will be able to get more sound compared to when they both move in opposite direction. Thanks so much for watching. Hope to see you in our next class, and please do not forget to subscribe and click on the notification button. Thank you.